In the mid-20th century, the geopolitical landscape was defined by the simmering tensions of the Cold War. As the United States and the Soviet Union engaged in a dangerous game of technological one-upmanship, intelligence gathering became paramount. The need for eyes in the sky, capable of peering deep into enemy territory without detection, drove an unprecedented push for aerial reconnaissance. But this pursuit was not without severe risks, as the world was dramatically reminded of in 1960. The stakes for covert surveillance were about to be raised to an unimaginable altitude. May 1, 1960, marked a critical turning point. A US U-2 spy plane, piloted by Francis Gary Powers, was shot down over Soviet airspace. This incident, widely documented by the US State Department and Soviet accounts, revealed a stark truth: even high-altitude aircraft were no longer invulnerable to advanced Soviet surface-to-air missiles. The U-2, once considered untouchable at over 70,000 feet, was proven to be well within reach of new defensive technologies. The intelligence community understood a radical new approach was needed, one that transcended existing aerial capabilities. In the wake of the U-2 debacle, the Central Intelligence Agency, or CIA, sought a clandestine replacement. They turned to the legendary Lockheed Skunk Works division, led by the enigmatic aerospace engineer Clarence Kelly Johnson. The directive was clear: design a reconnaissance aircraft that could fly faster and higher than any existing threat, effectively making it invulnerable. This top-secret endeavor, initially known as a Project Archangel, aimed not just for an incremental improvement, but for a revolutionary leap in aviation. The challenge was immense, demanding solutions to problems never before encountered. Under intense secrecy, Kelly Johnson's team at Skunk Works began their work, culminating in the A-12 Oxcart. This single-seat reconnaissance aircraft, which first flew in April 1962, served as the direct predecessor to the state Route 71. The A-12 pushed the boundaries of aeronautics, achieving speeds exceeding Mach 3 and altitudes above 90,000 feet. According to CIA historical documents, the A-12 proved the feasibility of ultra-high-speed, high-altitude flight for sustained intelligence missions, paving the way for its more famous successor. It was a testament to Johnson's belief that speed is life. Achieving and sustaining Mach 3 meant overcoming extreme aerodynamic heating, a phenomenon that would melt conventional aluminum airframes. Kelly Johnson and his engineers, as documented in Skunk Works' official history, turned to titanium. This exotic metal, though incredibly strong and heat-resistant, was notoriously difficult to work with. It was brittle, prone to cracking, and required entirely new manufacturing techniques. The sheer quantity needed, combined with Cold War geopolitics, presented an unprecedented logistical challenge. Yet, without it, the dream of an untouchable spy plane would remain grounded. The United States had limited access to raw titanium, a strategic material controlled largely by the Soviet Union. According to Ben Rich, former head of Skunk Works' Lockheed Advanced Development Projects, the CIA orchestrated a covert operation to acquire the necessary titanium from the Soviets through shell companies and third countries. This audacious plan, a true act of Cold War subterfuge, secured the essential material for the very aircraft designed to spy on them. This clandestine procurement was a crucial, if ironic, element in the SR-71's genesis, highlighting the extreme measures taken. In 1964, President Lyndon B. Johnson officially announced the existence of the state Route 71 Blackbird. Originally designated RS-71 for reconnaissance strike, President Johnson famously transposed the letters during his announcement, cementing the state Route 71 in history. This twin-engine, two-seat aircraft was a direct evolution of the A-12, designed for broader operational roles. Its distinctive black, radar-absorbing paint scheme, meant to reduce its radar cross-section, earned it the iconic Blackbird moniker. Its public unveiling marked a new era in strategic reconnaissance, signaling America's commitment to maintaining an intelligence edge. At the heart of the Blackbird's astounding performance were its two Pratt & Whitney J58 engines. These weren't ordinary jet engines. As detailed by Pratt & Whitney's historical archives, the The J-58 was a hybrid engine, functioning as a turbojet at lower speeds and seamlessly transitioning into a ramjet at Mach 2.2 and above. This innovative design, crucial for Mach 3+ sustained flight, effectively bypassed the compressors and turbines, allowing air to be compressed solely by the aircraft's forward motion. This engineering marvel was the key to unlocking speeds previously thought impossible for an air-breathing engine. A peculiar characteristic of the State Route 71, directly related to its Mach 3 capabilities, was its tendency to leak fuel while on the ground. The panels of the aircraft, designed with precision gaps to allow for extreme thermal expansion during high-speed flight, meant that at ambient temperatures, the fuel tanks were not perfectly sealed. According to former State Route 71 pilots, this was not a defect but an intended design feature. It required the aircraft to be partially fueled, then topped off mid-air after reaching cruise altitude and speed, where the expansion would seal the leaks. This unique quirk underscored its specialized purpose. Due to its design, a standard State Route 71 mission commenced with a partial fuel load and an immediate rendezvous with a KC-135Q tanker. This specialized tanker carried JP-7 fuel, designed specifically for the Blackbird's J-58 engines. According to the SR-71's operational manuals, the initial air-to-air refueling took place shortly after takeoff, allowing the aircraft to reach its operational altitude and achieve Mach 3+, where the airframe would expand and seal itself. This complex ballet of precise timing and coordination was not merely a convenience, but a fundamental requirement for every mission. Operating the State Route 71 at Mach 3+ and above 80,000 feet subjected its two-person crew, a pilot and a reconnaissance systems officer, RSO, to conditions akin to outer space. They wore specialized full-pressure suits, similar to those used by astronauts, to protect against decompression sickness and extreme temperatures. These suits, detailed in NASA and Air Force historical documents, were crucial for survival in an unpressurized cabin at such altitudes, where a sudden loss of pressure would be instantly fatal. The cockpit itself, though advanced, demanded intense focus and precision from its highly trained occupants. The primary purpose of the State Route 71 was intelligence gathering, and its payload bay was equipped with the most sophisticated reconnaissance systems of its era. This included high-resolution cameras, such as the iTech KA-0102, capable of resolving objects mere inches in diameter from over 80,000 feet. It also carried advanced electronic intelligence, ELINT, sensors to detect and analyze enemy radar signals, and side-looking airborne radar, SLAR, for mapping terrain regardless of weather. These systems, as described in declassified intelligence reports, allowed the Blackbird to capture vital information across vast swathes of hostile territory, providing an unparalleled bird's-eye view. The SR-71's operational deployment began with the Strategic Air Command, SAC, in 1968, marking its full integration into the U.S. Air Force's intelligence arsenal. Its mission spanned the globe, from the battlefields of Vietnam to the flashpoints of the Middle East, and over the heavily fortified borders of the Soviet Union and its satellite states. According to official USAF records, the aircraft performed critical reconnaissance during the Yom Kippur War and captured imagery following the Israeli nuclear reactor bombing in Iraq. Its presence alone was a powerful message: the US could see, and no one could stop it. This capability was a cornerstone of Cold War deterrence. The core of the Blackbird's invulnerability lay in a simple, yet profoundly effective, strategy: its speed and altitude. When an State Route 71 detected an incoming surface-to-air missile launch, its pilots executed a standard evasion maneuver. As recounted by numerous State Route 71 pilots in various interviews and official histories, the procedure was not a dramatic dogfight but a simple acceleration. By pushing the throttles forward, the aircraft would outrun the missile, leaving it behind. The sheer kinetic energy required to intercept an object traveling at Mach 3.2, 85,000 feet up, proved too much for contemporary missile technology. This became its ultimate defense. During its operational lifetime from 1968 to 1990, the State Route 71 faced thousands of missile attempts. Official U.S. Air Force records indicate that not a single Blackbird was ever lost to enemy action. The vast majority of these intercepts involved Soviet-made SA-2, SAR-3, SA-4, and SAR-5 missiles. While these threats often reached the SR-71's operational altitudes, their closing velocity was simply insufficient to catch an accelerating Blackbird. The pilots often reported seeing the missile trails below them, a stark reminder of the threats they faced, but ultimately, the aircraft's performance proved superior. It truly earned its reputation as the plane no missile could catch. A notable mission demonstrating the SR-71's unique defense occurred in 1986 during Operation El Dorado Canyon, the U.S. airstrikes against Libya. According to military historians, Colonel Gaddafi publicly declared that Libyan forces would shoot down any U.S. aircraft that entered their airspace. And State Route 71 was tasked with post-strike reconnaissance. During its mission, it was targeted by approximately 30 surface-to-air missiles. Each time, the pilot simply accelerated and turned, outrunning every single missile without taking a hit. It was a potent display of the Blackbird's unparalleled survivability under intense hostile fire, solidifying its legend. The State Route 71 was often compared to its predecessor, the U-2 Dragon Lady, but their operational philosophies were distinct. While both were reconnaissance aircraft, the U-2 relied on extreme altitude and stealth to avoid detection, which proved vulnerable. The State Route 71, as aerospace analysts point out, used speed and altitude not for evasion in the conventional sense, but as its primary defense against interception. The U-2 was a delicate instrument, while the Blackbird was a force of nature. This fundamental difference defined their capabilities and their ultimate effectiveness in contested airspace. The strengths of the State Route 71 were undeniable and unparalleled. Its ability to cruise at Mach 3.2, combined with its operational ceiling of over 85,000 feet, placed it beyond the reach of virtually all threats of its era. This allowed for rapid, deep penetration reconnaissance missions into hostile territory, collecting time-sensitive intelligence that no other platform could acquire. As noted by the National Air and Space Museum, the Blackbird could survey 100,000 square miles of territory in an hour, providing crucial strategic insights that were simply unobtainable through other means. Its speed and reach were its ultimate assets. Despite its technological prowess, the State Route 71 had significant weaknesses, primarily centered around its exorbitant operational cost and logistical complexity. According to Air Force budget reports from the 1980s, each flight hour of the Blackbird was immensely expensive, dwarfing that of other combat aircraft. Its specialized fuel, titanium construction, and unique engine maintenance requirements demanded a dedicated infrastructure and highly trained personnel. The aircraft also lacked any offensive weaponry, making it purely a reconnaissance asset, relying solely on its speed for survival. These factors would ultimately play a role in its eventual retirement. By the late 1980s, the strategic landscape began to shift. Satellite reconnaissance technology had advanced considerably, offering continuous global coverage without risking human pilots. Concurrently, the operational costs of the State Route 71 remained a significant burden on the defense budget, and the Soviet Union itself was showing signs of internal strain. These converging factors led to discussions about the Blackbird's future. The incredible machine that had defied every missile began to face a new, insidious threat: obsolescence in an evolving intelligence world. The decision loomed large over the future of strategic reconnaissance. In 1990, after 2 decades of service, the United States Air Force officially retired the State Route 71 fleet. The decision, cited by the Department of Defense, was primarily due to escalating operational costs and the increasing capabilities of spy satellites. While undeniably a marvel, its specialized nature meant maintaining it was disproportionately expensive compared to the versatility and endurance of orbiting assets. Despite protests from some within the intelligence community and Congress, arguing for its unique capabilities, the age of the Blackbird as a primary reconnaissance tool seemed to have passed, relegated to aviation history. However, the story of the Blackbird didn't end in 1990. During the mid-1990s, the state Route 71 experienced a brief, unexpected resurgence. Citing gaps in satellite coverage during regional conflicts, the U.S. Congress, backed by specific intelligence community requests, allocated funds to reactivate 3 SR-71s in 1995. These aircraft performed reconnaissance missions during conflicts in the Middle East and elsewhere. This temporary reactivation, documented by congressional records, underscored the fact that while satellites offered broad coverage, the Blackbirds still possessed a unique ability to provide rapid, on-demand, high-resolution imagery over specific hot zones, a capability satellites sometimes lacked. The second act for the Blackbird was short-lived. In 1998, the state Route 71 fleet was permanently retired, this time by an act of Congress. The arguments for its unique capabilities were ultimately outweighed by continued budgetary pressures and the rapid advancement of drone technology and more responsive satellite systems. The remaining operational aircraft were sent to museums, marking the definitive end of an extraordinary era in manned reconnaissance. Its final flight, documented by the Smithsonian National Air and Space Museum, saw it set a transcontinental speed record from Los Angeles to Washington, D.C., a final testament to its enduring speed. The historical impact of the state Route 71 is profound. It pushed the boundaries of aeronautical engineering, materials science, and human physiology. Its existence alone served as a powerful deterrent during the Cold War, demonstrating American technological superiority and the ability to gather intelligence anywhere, anytime. According to aviation historians, the lessons learned from its design and operation directly influence subsequent aircraft development, particularly in areas of high-speed flight, radar stealth, and advanced materials. It was a tangible symbol of innovation that forced adversaries to constantly reconsider their defenses. The legacy of the state Route 71 Blackbird endures, cemented by its unmatched record, 0 losses to enemy action. While its missions are now flown by unmanned drones and sophisticated satellites, no aircraft has ever combined its manned reconnaissance capabilities with such absolute impunity from interception. It remains a testament to what is possible when engineers are given a seemingly impossible challenge and the resources to meet it. The Blackbird represents the pinnacle of a particular era of aviation, a time when human courage and ingenuity pushed the limits of the atmosphere itself, remaining truly untouchable. Even today, the SR-71's performance figures stand as benchmarks. Its legacy continues to inspire the next generation of aerospace endeavors, particularly in the realm of hypersonic flight. As contemporary military strategists and aerospace companies like Lockheed Martin explore aircraft capable of Mach 5 and beyond, the challenges of heat, materials, and propulsion echo those faced by Kelly Johnson's team decades ago. The Blackbird proved that extreme speed is indeed a viable defense and a powerful intelligence asset. The race for air superiority still involves pushing the very edge of the atmosphere, a race the state Route 71 once dominated. The Blackbird routinely operated at altitudes often considered the very edge of space, with the pilot seeing the curvature of the Earth and the blackness beyond. This realm, where the air thins dramatically and temperatures plummet, was its domain. The physiological and engineering challenges overcome to allow sustained flight in this environment were immense. As retired state Route 71 pilot Brian Shull often recounted, flying the Blackbird was less like flying an airplane and more like navigating a spacecraft. It was a frontier where man and machine achieved an unprecedented symbiosis for intelligence gathering. Beyond its operational prowess, the state Route 71 holds numerous official world records for speed and altitude. On July 28, 1976, state Route 71 set an absolute speed record of 2,193.167 miles per hour, Mach 3.3, and an absolute altitude record of 85,069 feet in sustained horizontal flight. These records, certified by the Fédération Aéronautique Internationale, FAI, still stand to this day for air-breathing aircraft. They are not merely numbers, but concrete evidence of an engineering triumph that pushed the very limits of aviation and showcased its raw, unadulterated power. Its performance remains a benchmark for aircraft design. The Blackbird was a complex symphony of interconnected systems, each critical for its mission. From its advanced navigation system, using an inertial navigation unit updated by stellar observation, to its thermal management systems that dealt with surface temperatures reaching hundreds of degrees Fahrenheit, every component was on the cutting edge. Its unique fuel, JP-7, also acted as a coolant for the aircraft systems before being routed to the engines. This intricate interplay, meticulously detailed in engineering reports, allowed the State Route 71 to operate reliably in an environment that would destroy lesser machines. While often referred to as stealthy, the SR-71's radar cross-section was not truly minimal by modern standards. However, its design incorporated several features to reduce its detectability. The dark paint was radar-absorbent, and its unique chine body shaping helped deflect radar waves away from the source. According to Lockheed Skunk Works engineers, the true stealth of the Blackbird was its speed. By the time radar detected it and a missile could be launched, the State Route 71 would be miles away. It combined aspects of stealth with an overwhelming defensive attribute, pure velocity. The pilots and reconnaissance systems officers who flew the State Route 71 were a unique breed of aviator. Selected from the U.S. Air Force's elite, they underwent rigorous training, not only for high-speed, high-altitude flight but also for the complex systems onboard and the solitary nature of their missions. Many former pilots, in interviews, described the immense trust they placed in their aircraft and in each other. Their valor and skill were as integral to the Blackbird's success as its revolutionary technology. They were the human element that made that impossible missions a reality, operating at the very limits of human endurance. The State Route 71 proved its strategic worth repeatedly during moments of international crisis. During the 1973 Yom Kippur War, it provided crucial intelligence on troop movements and missile sites, offering real-time insights that were vital to decision-making. Later, it monitored sensitive regions like North Korea and the Middle East, offering a persistent, high-value collection asset. According to declassified White House intelligence summaries, the imagery and electronic intelligence gathered by the Blackbird often shaped U.S. foreign policy and military strategy. It was a silent, swift guardian of national security interests. Beyond its tangible intelligence output, the State Route 71 also served as a profound psychological deterrent. The knowledge that the United States possessed an aircraft capable of penetrating any airspace at will, without fear of interception, created a significant psychological advantage. Adversaries were forced to expend vast resources on developing missile systems that ultimately proved futile. As military strategists often note, the very existence of the Blackbird complicated enemy planning and instilled a sense of technological inferiority. It was a silent, intimidating declaration of power that resonated globally. The decision to retire the State Route 71 was met with considerable debate and reluctance within the defense community. Many argued that its unique speed-based survivability was irreplaceable, even by satellites, which had predictable orbits and could be tracked. Retired pilots and intelligence officers advocated for its continued service, highlighting specific scenarios where only a Blackbird could provide the necessary immediate reconnaissance. However, the sheer cost, combined with the shifting priorities of a post-Cold War world, ultimately sealed its fate. It was a testament to its value that its departure was not universally welcomed. Even decades after its final flight, the State Route 71 Blackbird continues to captivate the imagination. Its sleek, menacing form, combined with its legendary performance, has made it an icon of aerospace engineering. Featured in countless documentaries, books, and even popular culture, its story resonates with anyone fascinated by the limits of technology and human ambition. The anecdotes of its pilots, such as the famous faster-than-a-speeding bullet story, have become part of aviation folklore, perpetuating the mystique of the spy plane that truly was untouchable. The design and operational experience of the State Route 71 offer crucial lessons for modern air power. The emphasis on speed and altitude as defensive mechanisms, the challenges of thermal management at hypersonic velocities, and the integration of advanced sensors remain highly relevant to today's aerospace development. As military planners confront the proliferation of advanced air defenses and the need for persistent intelligence, the Blackbird's paradigm of unavoidable reconnaissance continues to inform strategies, even if the platforms themselves have changed. Its principles are foundational to the pursuit of tomorrow's air dominance. The Blackbird's development and operational costs were astronomical, even by today's standards. Each state Route 71 was reported to cost over $30 million in 1960s dollars, equivalent to hundreds of millions today, according to inflation calculators and defense expenditure reports. This figure doesn't even account for the specialized fuel, maintenance, and training required. While its capabilities were unparalleled, this extreme investment underscores the lengths nations would go to in the Cold War for a decisive intelligence advantage. It also highlights the constant tension between capability and affordability in defense procurement. The J-58 engine's unique design required an equally unique fuel, JP-7. This high flashpoint, thermally stable fuel was specifically formulated to withstand the extreme temperatures and pressures inside the engine at Mach 3+. It was also notoriously expensive and difficult to produce. According to former Lockheed engineers, the fuel also had to act as a heat sink, absorbing heat from various aircraft systems before being burned. The logistical challenge of producing and distributing JP-7 to every base the state Route 71 operated from was a constant, costly endeavor, highlighting the specialized ecosystem required for the Blackbird. Operating the Blackbird was an exercise in extreme precision and complexity, far beyond conventional flight. From the intricate pre-flight checks, which could take hours, to the precise in-flight refueling rendezvous and maintaining a narrow thermal envelope at Mach 3, every aspect demanded exacting standards. Pilots recall the critical role of the Reconnaissance Systems Officer, RSO, in managing the array of sensors and navigation systems, often in complete radio silence. This wasn't merely piloting, it was managing a finely tuned, high-speed laboratory, pushing the limits of both human and machine capabilities across hostile skies. While the state Route 71 predates true stealth aircraft like the F-117 Nighthawk, it pioneered several concepts. Its radar-absorbing paint and unique shape were early attempts to minimize radar detection, as noted by stealth technology historians. However, its primary defense was its sheer speed. This presents an interesting historical debate. Was the state Route 71 a proto-stealth aircraft, or did it simply demonstrate that speed could negate detection? The answer likely lies in a combination, showcasing that different approaches can achieve similar defensive outcomes against a given threat. Its innovation certainly paved the way for later, more dedicated stealth platforms. The state Route 71 represented a different kind of warfare, one of information superiority rather than direct combat. Its missions were not about engaging the enemy but understanding them. This coldy aspect of Cold War operations, relying on intelligence gathering to prevent escalation, was critical. The Blackbird provided the eyes that allowed strategic planners to make informed decisions, preventing potential conflicts or gaining an upper hand in negotiations. It operated in the shadows, its impact measured not in destroyed targets, but in the clarity of information it delivered, proving the adage that knowledge is power. For the few who flew it, the state Route 71 offered an unparalleled perspective of the world. From 85,000 feet, the Earth's curvature was distinct, the sky above a deep violet, almost black. Pilots often described seeing entire states or multiple countries simultaneously. This unique vantage point was not just for reconnaissance, it provided a profound sense of isolation and wonder. As many former state Route 71 pilots recount, witnessing this view was a privilege, a reminder of both the vastness of the planet and the incredible engineering that allowed them to soar above it, observing in silence. Today, the surviving SR-71s are revered museum pieces, attracting millions of visitors annually. Each aircraft, preserved in institutions like the Smithsonian National Air and Space Museum and the National Museum of the U.S. Air Force, tells a story of innovation, risk, and unparalleled achievement. They serve as tangible links to an era when technological prowess was a critical determinant of global power. These silent, black giants continue to inspire awe and curiosity, a lasting tribute to the engineers, pilots, and ground crews who pushed the boundaries of what was thought possible in aviation. While the state Route 71 achieved unprecedented immunity from interception, the arms race between aircraft and air defenses is perpetual. Today's integrated air defense systems are vastly more sophisticated, capable of detecting and engaging targets at greater ranges and with higher precision. However, the Blackbird's fundamental principle, that overwhelming speed and altitude can defeat missile threats, remains a valid, if increasingly difficult, strategy. The quest for invulnerable flight continues, driven by the same imperative that spawned the state Route 71, the need to see, without being seen or caught. This continues to be a central challenge for aerospace engineers. The state Route 71 pushed the limits of human endurance and machine reliability. The intense G-forces during acceleration, the extreme heat, and the isolation of high-altitude flight tested every aspect of its cruise. Yet, they performed flawlessly, mission after mission. Their commitment to the aircraft and its mission epitomized the Cold War ethos of technological superiority. The Blackbird proved that with enough ingenuity and bravery, seemingly insurmountable technological barriers could be overcome, allowing humans to operate effectively in environments previously deemed hostile and unreachable, making it a true testament to human ambition. The state Route 71 is a direct product of Kelly Johnson's 14 Rules of Management at Lockheed Skunk Works. This philosophy emphasized small teams, minimal bureaucracy, and direct communication, allowing for rapid innovation and problem-solving. This agile approach was instrumental in developing such a complex aircraft under immense pressure and secrecy. The Blackbird stands as a prime example of how streamlined, focused engineering can achieve breakthroughs that large, bureaucratic projects often struggle with. Its success is as much a tribute to its management approach as it is to its technical design. Much of the SR-71's mission history remains classified, hinting at the true depth of its impact. Only fragments of its operational life have been declassified, revealing its critical role in numerous international incidents. As more information emerges over time, the full scope of its intelligence contributions continues to be unveiled. These future revelations will only serve to underscore the Blackbird's significance, further solidifying its status as an unparalleled tool in the annals of espionage. The full story of what the state Route 71 saw may never be completely known, adding to its legendary status. In conclusion, the state Route 71 Blackbird represents a unique chapter in aviation history, a singular achievement born from Cold War necessities. Its development pushed the boundaries of materials science and propulsion. Its operational record, with zero losses to hostile action despite thousands of missile attempts, definitively proved its core design philosophy, that speed and altitude could render any contemporary threat obsolete. From its clandestine birth to its enduring legacy in museums, the Blackbird remains a powerful symbol of human ingenuity, technological superiority, and a testament to the spy plane that truly no missile could catch.